So let's look at the case where now we have a less than 1. Okay, in other words, a is negative and clearly different from 1. So here again, we are factorizing. As I said, in this case, we can see there's a negative 1. Remember the invisible math. So I'm going to take out the negative 1 here. And once again, this is the thought process. Negative x squared divided by negative 1. You can see negative takes out negative. So I'm left with a positive x squared. Same thing here. 3x divided by negative 1. You can see you're going to have a negative 3x. Negative 2 divided by negative 1. That's going to be a positive 2. Very, very important caution there. And then finally, I'm now going to start with the portion law approach to factorization. And this is how we're going to roll. I know that I need a sum from this expression that is going to give me 3x. Remember, I'm working with the expression inside the brackets. Then this 3x comes from the middle term, and I always swap the sign, okay, of the coefficient. So I should not be having 3x here, my bad. I should be having just 3. The product should give me a 2. Then I know that the two numbers, the sum will be such that I divide it by 2, then add a number that I'm going to find soon, and then subtract the same number in the other case. I find this number using the product, and so I'll say 3 over 2 plus u, in this case, into 3 over 2 minus u should give me a 2. And I know whatever the case may be, whichever day it may be, whether it's raining or sunshine, I will always have the difference of 2 squares here. So in this case, I just square the numerator and the denominator, then I'm good. That's 2, right? So you see now I've got 9 over 4 here. Let me just write that down. I've got 9 over 4, and I'm going to actually subtract 2. So I get a quarter is equal to u squared. Then from here, I get that I'm going to take u as 1 over 2. Remember, I always take positive 1. So get used to that. Okay, you can also make it your convention, or if you want to be extra and take the negative 1, that's still good with me. So my solutions are going to be as follows, and I can use a different pen just to know that I'm on the solution step now. My first solution will be 3 over 2 plus 1 over 2. And I can see that this is 4 over 2, and that's a 2. The second solution will be 3 over 2. I'll call this x2. 3 over 2 minus a half. And I can see that's 2 over 2, and that's just a 1. So if I have x1 equals to 2, then x minus 2 is 0. That's a factor. And similarly, x minus 1 is also a factor. Therefore, my factorized form is x minus 2 into x minus 1. And I can just substitute this down there and write my final solution as negative 1 into x minus 2 into x minus 1. Just like that, I am done. Folks, I'm going to challenge you to go ahead and try factorize the following on your own. I know it might look really scary, like why so many problems, Mr. G? It's because I just showed you an unconventional, in other words, a method that you are not used to. Probably if you show your teacher this, your teacher will be surprised as well. Unless, of course, they've done the research that I've done also, then we're good. But I've given you 16 problems on this one. Please go ahead and see if you can adapt to this method. I'm sure you want to use this method, even if you have other methods that are working and all that, but I'm pretty sure when you get here, you will want to consider it. Maybe when you get there, you may want even here and there. And you'll see why. The reason is obvious. The coefficient of x squared is actually not 1. So that's why I'm actually challenging you. This one is going to be an interesting one. Okay, you're welcome to discuss this one with me. And of course, maybe 14 and 15 might. 13 is just an abstract one, but you can see actually you don't really need to go a long road with factorizing that one. Let me not give it away, but just give it a try. So the problems that I've circled, you probably want to try the portion law method, the one that I just showed you here. I know there are others, you might use your traditional one. I hope, for example, you can see that number 3 is just difference of 2 squares. Okay, I just hope you can. So yeah, go ahead, guys, and make me proud. I'll catch you later.